Let's consider the preparation and launch of a project for calculating the flow around a cylinder. We'll take the cavity project as the basis for the new project. We'll copy it, change the name to cylinder, and delete unnecessary files and folders, such as calculation results, mesh data, and technical files. Then, it's necessary to configure the configuration files for initial and boundary conditions, fluid properties, control dict, block mesh dict, FV solution, and FV schemes, as was described in previous lessons. In our project, these files have already been modified. We'll open the terminal and activate the OpenFOAM environment. After that, we'll generate a new computational mesh using the block mesh utility. Its files will appear in the constant/polymesh folder. In this project, compared to the cavity project, two important changes have been introduced: the ability to launch calculations on multiple processors, and the calculation of forces acting on the body during the computations. To configure parallel computations, a configuration file decompose partict is created in the system folder. This file specifies the decomposition method for the computational domain into subdomains and the number of subdomains, which corresponds to the number of processors used. For force calculation, a post-processing function must be added to the control dict file. This function will calculate the forces exerted on the body by the fluid. Before launching calculations in distributed computing mode, data needs to be generated for each processor. To do this, we'll run the decompose par utility. It will divide the computational domain into parts. Data for each part will be saved in the processor 0, processor 1, and so on folders, which will appear in the project directory. In each of these folders, you can find the initial and boundary conditions and files describing the mesh architecture within that part of the domain. The calculation launch in parallel mode is performed by the command mprun-np8 icofoam parallel. When using this command, all messages related to the problem solution will be output to the console. The calculation can be interrupted with the Ctrl+C key combination. The calculation results are saved in the processor folders within the directories corresponding to the time steps. Each folder contains data relating only to the domain part, managed by the specific processor. The results of the post-processing functions are saved in the post-processing folder in the project directory. Inside it, a forces folder is created, corresponding to the configured function. Inside the forces folder, subfolders will be created with names corresponding to the initial calculation time. Here it is, time 0. Within these folders, the calculation results are stored, such as the coefficient link to .dat file, which contains the calculated coefficients of the hydrodynamic force acting on the cylinder. To avoid overloading the console with messages, the launch command can be modified by adding the option to write messages to a log file. Now all technical messages will be written to the outlog link to .log file, and the console will remain free for other tasks. The calculation can take a significant amount of time, so it's recommended to monitor the progress via the log file. Pay attention. If the calculation is launched from the initial time moment, here it is, time 0, and the post-processing folder was not deleted, then instead of overwriting the coefficient link to .dat file, a new file named coefficient_0 link to .dat will be created.